Why are ACID properties crucial for Python databases? Imagine you are building a Python application that manages bank accounts. You want to transfer money from one account to another without losing any data or causing errors. This is where ACID properties come into play. They are the rules that keep your data safe and consistent when working with databases in Python. When you connect Python to a database and perform actions like inserting, updating, or deleting data, these rules make sure everything stays reliable. Let's break down what each part of ACID means. Atomicity is like a light switch. Either everything in a transaction happens or nothing does. For example, if your Python code moves money between accounts, atomicity guarantees that both the debit and credit happen together. If something goes wrong, it cancels the whole process, so no partial updates occur. Consistency makes sure your data always follows the rules set by the database. If you have a rule that account balances cannot be negative, consistency ensures that no transaction breaks this rule. Isolation is about keeping transactions separate. When many Python processes access the database at the same time, isolation prevents them from seeing each other's incomplete work. This stops errors like one process reading data that another process is still changing. Durability means once a transaction is confirmed, it stays saved. Even if the system crashes right after, the data remains intact. This is often achieved with special logs that record changes on disk. In Python application development, understanding these properties is important because they protect your data during complex operations. They also allow multiple users or processes to work safely at the same time. If a transaction fails, ACID properties help roll back changes so your database stays correct. When you write Python code that interacts with databases like PostgreSQL, MySQL, or SQLite, these rules are usually built in. Python libraries such as Scikit-2 or SQLite 3 help manage transactions that follow ACID principles. Most of the time, you start a transaction, do your database operations, and then decide to commit or roll back. Thanks to ACID, you can trust that either all your changes are saved or none are. This makes your application more reliable and your data more trustworthy. Knowing about ACID helps you design Python programs that handle data safely, especially when many users are involved or when your operations are complex. It is the foundation that keeps your database interactions stable and predictable.